Ohm's law exercises. In this video, we are using Ohm's law to further investigate circuit behavior by computing voltage, current, and resistance where needed. Below are the concepts we're going to revolve around, and yes, we're using graphs to express them, so fasten your seatbelt and get ready to go. Current in the circuit is 1 amp. Determine what the current will be when the voltage is doubled. We know that current equals voltage divided by resistance by Ohm's law, but this gives 1 amp as we see in the problem, so it equals 1 amp. In A, they say the voltage is doubled. This means that VA equals 2V. V being the voltage we had before that gave us 1 amp in the circuit. So if we compute current for the situation in A, we get 2V divided by R. V here is the voltage we had before that gave 1 amp. I want this to be clear. This equals 2V divided by R. And V divided by R, we have found that it was 1 amp in this relationship. So we get 2I, which equals 2 amps. So if we double the voltage, current increases. This is what we expected by Ohm's law, and it's in action here. B. The voltage is reduced to 80% of the initial value. So VB equals 0.8 V. IB, current for situation B, equals 0.8 V divided by R, the voltage in B, which equals 0.8 multiplied by I equals 1 amp. We get 0.8 amps. Again, notice that we have decreased the voltage. Current has decreased. We had 1 amp, now we have 0.8 amps. In C, voltage is increased to 150% of the initial value. Voltage increases in C. IC equals VC. But how big is VC? VC equals 1.5 V. And we get 1.5 V divided by R, which equals 1.5 amps. Again, the voltage is increased, current increases. We had 1 amp, we have 1.5 amps. Current in the circuit is 100 milliamps. How will the current behave if the resistance is tripled? We know that current equals 100 milliamps, so current equals voltage divided by resistance, which equals 100 milliamps. In A, they tell us the resistance is tripled. This means RA equals 3R. If we use this resistance to compute the current in A, we get current in A equals voltage divided by the resistance in A, which equals 3R. We get 1/3 of V divided by R, which equals 100 milliamps divided by 3. This equals 3.3 milliamps. Notice that we have increased the resistance by tripling it, so current decreases. This is what we expected by Ohm's law. In B, they say that the resistance is increased by 30%. This means RB equals 1.3 R. In C, they say the resistance is decreased by 30%. This means RC equals 0.7 R. By using these values, you can replace in the formula yourself and find out how the circuit behaves. So I leave this for you. Current in the circuit is 2 amps. What will the current be if the voltage is tripled and the resistance doubled? This is a tricky one, but we start slowly. So current equals voltage divided by resistance, which equals 2 amps, as they say in our problem here. So we split our circuit into two states. Let's say that it was in state 1, the state that gave 2 amps. It was B1 and R1. We go in state 2, where V becomes 3V and R becomes 2R, because the voltage triples and the resistance doubles. If we compute I2 to mean in state 2, we get 3V divided by 2R. Ohm's law here. We get 3 divided by 2, V divided by R, but V divided by R gives I. Here we had I in state 1, which equals 2 amps. So we get 3 divided by 2 multiplied by 2 amps, because V divided by R equals 2 amps in state number 1. And we get 3 amps for our circuit. Consider the voltage values given in the table below. What are the resulting current values in the circuit? We have to plot our results in a simple graph. We apply Ohm's law on each of these values. I equals voltage divided by resistance. So here, voltage equals 0. Resistance equals 10 ohms. So 0 divided by 10 equals 0 amps. Current is expressed in amps here. We get to 10 volts divided by 10 ohms, we get 1 amp, and we keep doing this. Now we have to plot what we have found in the circuit and put in our table here. When the voltage equals 0, current equals 0 amps. So we have a point here, 0 volts and 0 amps. It's here. When voltage equals 10, current equals 1, and 10, 1, we have a point here, and we keep doing this also. Here we have finished plotting our points in the plan, and we can see the resulting points. So notice that for each voltage value there is a corresponding current value, and the point where these lines meet is the one we're interested in. So if we draw a line that connects all these points, we get a graph that describes the behavior of our circuit.